Okay, so we're starting implicit differentiation. You have to know the difference between implicit and explicit forms of functions, and we'll go over that in a second. Alright, but one big note here is right here. So we haven't really been showing this step. Okay, remember d dx, that's a verb. That means take the derivative. When we take the derivative of y, we get dy dx. Okay, because we're taking the derivative with respect to x. When we take the derivative with respect to x of x, the derivative of x is just 1. And that's because it's dx over dx, which is what we've been doing. Okay, so we're going to have to actually write that out a little bit more when we do these problems. Alright, explicit form, when an equation is solved explicitly for y, we say that that's an explicit form. If it's an implicit, the x and the y are together, or you can't explicitly solve it for y easily. Alright, so notice these are the same equation. So we're going to show two different ways of solving these derivatives here using both the explicit and implicit form. Alright, find the derivative of both. Y equals 2 over x and x times y equals 2. Okay, so the first thing that we should do is show that we are taking the derivative. Now you're going to see that already on my notes because you know how good my pen works. So I was just trying to save a little bit of time by writing it already. So we're taking the derivative. I'm showing that I'm taking the derivative of both sides. Alright, so the derivative of y with respect to x is dy dx. Okay, the derivative of 2 over x. Well, remember 2 over x, that's 2x to the negative first. So that's going to be negative 2 times x to the negative 2. Or I could just rewrite that as negative 2 over x squared. Alright, and that's our dy dx. That's the way we know right now by using the power rule, or if you really want, you could go all out and use the quotient rule. Alright, so that is one way. Now we're going to learn a way to just leave it like this and then take the derivative. So I'm going to show that I'll take the derivative of both sides. Okay. So I'm taking the derivative with respect to x on both sides. Alright, so here we have two variables being multiplied, so we have to use the product rule. So the first times the derivative of the second. Well, the derivative of y is dy dx. Okay, plus the second times the derivative of the first. The derivative of x is dx dx, or just 1. So I don't have to write that. Alright, now let's move to the other side. The derivative of 2, or any other constant, is simply 0. And we're trying to solve for dy dx. So we're almost there. So x times dy dx, if we just move over that y, okay, and then the last step would be divide both sides by x. Negative y, oh gosh, that's an x on the bottom there. Negative y over x. So that looks exactly the same, right? Well, not quite, but we already know what y is, okay? So we can plug that in. So I'm just going to show you how we could show that that's exactly the same. Y is 2 over x. And x is still there. Alright, multiplied by the reciprocal, if you want to get it back into your regular form. So this turns into 1 down here, and we're going to see that it ends up being, oh, that's a 2. That doesn't look like a 2. Okay, it's exactly the same as negative 2 over x squared. So we get the same thing. And we're going to see that sometimes it's more convenient just to leave it in terms of x and y. Alright, it's good to just practice setting this up. And like I said, I'm going to have some things already there because I'm just trying to save a little bit of hassle. My computer moves slower when I'm using this recording software. Alright, so we have a business model whose success is given by that equation there. So we have this nice long equation, all kinds of different variables. M is the amount of money spent on advertising, E is the size of employee staff, O is the operating cost, and N is unforeseen natural disasters. So if we want to analyze the success, this whole thing, if we're only changing, we're trying to figure out how the success will change if we tweak the amount of money. So we're going to try to take the derivative of the s function, and we have to show that we're doing it both sides, with respect to m. So this ddm, this is going to tell us how each thing changes based on the amount of money we spend on advertising. So ds dm, how the success is changing with respect to the amount of money spent on advertising is going to be equal to, so the derivative of this is 4m, and for this time I'll write it, the derivative of m with respect to m. Okay, the next one, 3 times 3 is 9, e squared. Okay, but then we're taking the derivative of m, we're trying to see, the derivative of e with respect to m. How does the employees on staff change by the amount of money we spend? Okay, minus 20 o to the third do dm, and then the last one, 6, let's just do that on the side, 6 times 2/3 would just be 4. Okay, minus 4n to the fifth dn dm. Alright, so then that's all you have to do. We don't know how the money is going, or how the employees are going to change depending on how much money we change, or how the operating costs change. If we did, we could plug those things in, and this will come into play later. But for now, we could just leave it just like that. Alright, so I'd like you to try the other two. If you want to pause the video so you have the setup of the equations, and then bring it into class so we can discuss it. Okay, so moving on now, there's some important things when we're implicitly differentiating or taking the derivative without solving for a variable first. You have to show that you're taking the derivative of both sides. Okay, just like it's a lot to write, but it sets up what you're doing. Alright, and that's why I went ahead and did that on each of my problems, so I don't have to waste time writing it, because my pen works so terribly. Alright, so it doesn't matter if you use dy dx or y prime. It's just sometimes if you're in a hurry and you write y prime, sometimes you might think it's y to the 1 or just y, and you might drop it. So if you write dy dx, it's hard to mistake that for y. They're not the same. Okay, so just be careful. If you want to save time, you could write y prime, but again, just watch that it doesn't turn into a 1. Alright, so let's try an example here. We're going to find the slope of a graph at a certain point by finding dy dx, then evaluating it there. Alright, so can you easily solve this for y? Probably not. So this implicit differentiation might save you some time. Alright, so the derivative of y with respect to x, or y cubed, will be 3y squared dy dx plus 2y dy dx minus 5 dy dx, lots of dy dx's here, minus 2x, and this would be dx dx, so we don't have to write that. And on the other side, the derivative of any constant is just 0. So our goal for the part A is just to find dy dx and then evaluate it. So anything with a dy dx, keep it on one side. Everything else, move it over. Alright, so if I move over this 2x that's over here, everything else has a dy dx in it. So I could factor that out. Okay, and if we see what's left, we have 3y squared plus 2y minus 5. Alright, and my last step is to find dy dx, so I could divide by that whole part. So dy dx equals, we have 2x on the top, all over 3y squared plus 2y minus 5. So now I've found dy dx, and I want to evaluate it when at the point 1, negative 3. Okay, so this is what I'm saying. Evaluate at the point negative 1, or, oh, sorry. Evaluate it at the point 1, negative 3. Negative 3. Alright, so to evaluate it there, just simply plug in those numbers. Okay, you can plug in those numbers yourself just to double check me here, but I believe that you should get 1/8. 1/8. Alright, so I don't have a lot of time right now, but the other part B, if you look at it, all you're doing, first just differentiate. Stop when you get to this. Oh man, alright, don't want to write through it. Come on. There we go. Alright, stop when you get right here, and instead of solving for dy dx, plug in your point. So plug in negative 3 for y, plug in 1 for x, and then you get numbers, coefficients next to dy dx. Solve, and you should end up with the same thing. Dy dx equals 1/8.